Welcome to the Inspires curriculum, developed through a collaboration between UMBC and the University of Maryland School of Medicine and funded by the National Science Foundation. As you can see, 5 modules are included in this curriculum, each targeting an important issue to society and including contribution by an expert in the field. This curriculum incorporates a number of different activities within each topic, including assessments of interest in student learning, hands-on activities, motivational videos, and an interactive online tutorial. The curriculum is focused around an engineering design challenge. Students first learn about the design process using the online tutorial, then are introduced to scientific principles related to the challenge. The curriculum guides the students step by step through the design process to ensure student success. Scientific principles are introduced in context using interactive animations that allow the student to explore the topics. For example, in the animation shown, students can explore how temperature influences the diffusion of molecules. Hands-on activities are also included in the curriculum to allow students to visualize a real example of the phenomenon.
When your teacher placed a drop of food coloring in hot and cold water, what happened? The coloring in the hot water diffused through the water faster than the coloring in the cold water. You can see very easily how temperature, just one of the variables we will discuss, affects diffusion.
Equations are introduced to help students understand how mathematics applies to engineering design and science. Students embark on simulations to evaluate different possible designs to meet the given engineering challenge. In this example, the goal is to create a system with high efficiency at the lowest possible cost. To motivate students as they begin the design challenge, an expert in the field discusses how future innovation can improve upon today's designs. Student teams then design, build, and evaluate their own system or apparatus.
For Joan and others suffering from kidney disease, life and quality of life depends on others. Those working in research, engineering, biotechnology, medicine, and other healthcare professions.
The future of dialysis, let's think really big. We've already gotten pretty good at a dialysis machine that sits in a dialysis here in a room, and a patient comes and she's attached to her machine, and her blood is flowing out of her body and returning, but she's sitting right here. Wouldn't it be amazing if we could miniaturize this? I would like a dialysis machine that was efficient enough that Joan didn't have to stay here for 4 hours, that Joan could stay here for 1 or 2 hours. I would like a dialysis machine that was simple enough that she and her family could take care of this at home and need not drive all the way into Baltimore to come in and see me. Come see me once a month instead of 3 times a week. I would like a dialysis treatment experience that is easier on the patient, not requiring anticoagulation, and with a safer range of blood pressure. Those would be goals for improving dialysis treatment.
I guess it would be great if you guys can get out there and make dialysis easy for us and invent new things, because you're holding the future in your hands, and we would really enjoy something new for our lives.
Accept the challenge to make a difference.
An important goal of the curriculum is to encourage students to enter careers in engineering and science. It is particularly important for women and minorities to be able to envision a future in these careers. A final motivational video is included to address this need.
There are many careers that can make a difference in people's lives. Hear about some of the possibilities from students and those actually involved. Find out how you can make your life contribute to helping others.
When we make these new observations, it's very exciting because it's never been made, and we actually have the opportunity to build on these observations and hopefully really discover how the kidney actually manages these electrolytes.
I want to be able to use kind of all the different sciences and math courses I've been taking, and chemical engineering seemed to be a good fit for me.
Just trying to figure out the answer, and professors try to throw in little tricks and stuff, and be able to say that you've conquered the problem. And
we want to use mathematics, equations, and different parameters to try to understand living systems.
The way the world works is based on math and science,
and it's very intellectually stimulating.
Engineering is more about problem solving, using what you know and different equations and skills that you have to solve the problem.
I actually plan on going to orthopedic surgery.
A lot of research is going on, and so a lot of these medications and new drugs that we come up with is a result of what we do here in the lab.
It's not exactly what you learned in school, but how you learned it. That the way of thinking you can apply to whatever you want.
I like the whole problem-solving aspect of it.
I want to use what I have and what I've learned to directly impact the lives of others.
I think just focusing on having good grades, and I think a big thing was definitely getting exposure to the different aspects of medicine.
I've done a couple internships both here and off campus. This summer, in fact, I'm going to do an internship in Hawaii for metabolic engineering.
I think the puzzle-solving aspect of it is a big part, but also the patient-doctor interaction.
I just think it'd be like a perfect job to be able to enjoy what I'm doing, enjoy biology, my chemistries, and also be able to kind of give back to society.
Specifically working with spinal cord injury patients and using electrodes and implants to help stimulate paralyzed limbs. I would define engineering as the study of basically how things work, what makes things tick. I mean, how else could you make a greater impact than that? Than to have basically no limit to what you can do, what you learn, and can continue to learn and build on it.
The Inspires curriculum, increasing student participation, interest, and recruitment in engineering and science.